Hey, if a line is tangent to the circle, then when you draw a radius to that tangent point of tangency, you get this right angle, right? So that's what I want you to add to your notes. If a line is tangent to the circle, then a radius drawn to the point of tangency forms a right angle. Okay, the point of tangency is like that point where the line hits the circle. Okay, so put that right up there. So why is that important? Well, the next 6 problems you do are going to ask you a question like this. All right, so they're going to draw something that looks like a tangent. And unlike the first 4 problems where you were trying to prove that it was definitely a tangent, they tell you, hey, assume the one that looks tangent is tangent. Okay, assume that it's a tangent. That's what they tell me in the direction. So, okay, if it's tangent, then when they drew the radius up to here, even if I don't draw this very accurately, I know because it's a radius drawn to the tangent line that it's a right angle. And then they have some lengths on there and they complete this out to here. And they say this, they go, one side is 20 right over here. This is 20 long right over here, and then they have this is 15, and they want to know, well, how big is x then? Okay, so we're going to use Pythagorean theorem, right? We're going to go 15 squared plus 20 squared equals x squared. Now I want to show you something that I would want, if you consider yourself super advanced, I want you to try the advanced technique. I'm going to divide this guy by 5, and I'm going to put down 3. And I'm going to divide this guy by 5, and I'm going to put down 4, because both of them are divisible by 5, right? So I divide this one by 5, it became 3. I divide this one by 5, it became 4. So what I really have is a 3, 4, 5 triangle. It's just 5 times bigger than that, right? It's 5 times bigger than a 3, 4, 5. So that means that the x value is 5 times 5, or 25. So it's really a 3, 4, 5 triangle, just 5 times bigger than that. If you ever can reduce the sides down, I want you to try to do that, because it'll make the Pythagorean theorem a lot easier, even if it's not a Pythagorean triple. Like, let's say this was 3 and it reduced down to 6, So it's a 3 and a 6, then you could still do Pythagorean theorem with the 3 and the 6, and then simplify it that way. So look, you don't have to do the Pythagorean theorem if you can do little tricks like that. And we're going to work on some of that in class. If you just went ahead and did the Pythagorean theorem with the 15 and the 20, it's going to work out just fine. All right. I want you to try the next 6 problems, and then we're going to touch base in class.